Welcome back, and I've got another really fun experiment to try today. What we're going to look at is the physics of hydraulics. So, as you know, I quite like my counterintuitive physics experiments, and this is another one of those. I've got two syringes here, and they're joined together with a plastic pipe, and in both syringes is some water. And what we're going to do is we're going to have a tug of war between these two syringes to see what happens. But it's going to be a slightly different kind of tug of war. Instead of a pulling one, we're going to use a pushing method here. So I've got the two syringes, and what I'm going to do is I'm going to put a force on the large syringe, and I'm going to put a force on the small syringe, and I'm going to ask you which one is going to win. In other words, if I put equal forces on both, which syringe will go down easiest? So before I start the experiment, I need to set these two up in a clamp stand. And whilst I'm clamping them, I'd like you to give some thought to which syringe will win the tug of war. Remember, what I'm going to do is I'm going to put a weight on the large syringe, and I'm going to put the same weight on the small syringe. So there's going to be a tug of war between the two, and which one do you think will win? So here goes. I've got two equal weights. They're approximately a kilo, so they're about 10 newtons each. Let's put them on top of the syringes and see which one wins the tug of war. And I think you'll see there, it's pretty convincingly the small syringe. So I wonder if that's what you expected would happen. I'm honestly not cheating by pressing down on the little syringe. The weight would fall off if I didn't hold it carefully. But every time, the small syringe wins. And perhaps there's one other thing I can do to prove to you I'm not cheating. Let's repeat the experiment and see what happens. And there's the small one winning. And if I can get the weight to balance, I can lift it up with the large one, but I really have to press quite hard. And if I let go, the small one still wins. So this is a really lovely example of hydraulics. And to explain hydraulics, we need to understand about pressure. We've got the same weight on each one of these syringes. We've got the same force, 10 newtons on this side and 10 newtons on that side. But the 10 newtons here is concentrated on maybe 1 centimetre squared, whereas the 10 newtons here is spread out over 4 centimetres squared. And if you remember, pressure is force over area. So the pressure here is 4 times the pressure on this side. So this one is always going to win. In other words, I would need to put 4 times the force on this side, on the big syringe, to equal out what the small syringe is doing. Well, there are lots of applications of hydraulics. You see hydraulic systems all over the place. But the main thing you'll notice is that if you want to lift a large force, if you want to overcome a large force with a smaller one, then you need to put the force on a smaller surface area. So if you think of the large jacks that lift cars in garages, the cars will sit on a big piston and go upwards, and the pump that pumps the hydraulic fluid in will have a very small cross-sectional area. So it'll have a very high pressure, and this machine magnifies the force. Well, I wonder if you guessed right in the first place, that in this situation, the small syringe will always win. There's so much more I can say about hydraulics, but I think that's enough for one little video. You've at least got an idea of what happens when we have equal forces on different cross-sectional areas. Hope you enjoyed that video, and I look forward to seeing you again next time.